Hi everybody, here we're going to go over the procedure for the next lab, which is going to be the Atwoods machine. So as before, don't forget to enter your student ID into cell A2. And so here you have the procedure written out here. So there's two parts to the experiment. And so let's look at the different sections of the lab. So as before, you're going to have while you're doing your experiments, you're going to enter your errors over here from your devices. And don't forget to enter units in SI units here. So here's the link. So if you press either of these two links here, they're going to take you to the same place. And it's going to be to this website here. And so you have your different, and you can see the way that this experiment is going to work is you're going to change these masses. And you're going to run the system. So let's begin by looking at the terms that you'll be looking at. There's going to be, you can see here, one mass rises, that's going to be the ascending mass, and one mass sinks, that's going to be the descending mass. So that's what you see here. So MA, that's the ascending mass, MD, that's the descending mass, and sigma M, that's the error in the mass. And you're also going to be measuring height, that's going to be given by the variable Y, time by the variable T, and acceleration variable A. And you have the corresponding errors for height, sigma Y, error for time, sigma T, and error for acceleration, sigma A. Next over here, you have the formulas you're going to use. There's going to be an equation for the experimental acceleration. That's going to be 2 times the final height divided by the final time squared. And then the theoretical acceleration is going to be given by this formula here. And then you have your formulas for percent difference, and you have your equation to calculate the error and acceleration. So now let's start to look at the experiment. So as you read the experiment, what it's going to tell you for part A here, so let's actually look at it. So you have part A and part B. So let's see where those two parts are. So right here is part A. You just data that you're going to enter. You're not going to type these numbers yourself, you're going to copy paste. And then you can see part B begins over here. And it's just a repeat, the format's pretty similar. So let's just look at part A. So for part A, you're going to read procedures. Let's see, it's going to be numbers 1 through 9. And I'm just going to give you an overview of how this experiment is going to work. I'm going to use different numbers, but it's going to be the same basic process. So just make sure you read these instructions in detail because I'm going to be using different numbers though. But the basic idea is that you're going to start off with a system, a balanced system. So let's say that you set these two masses to let's see here, let's say 175. Don't forget to convert this to kilograms. So this should be 0.75 kilograms. But I'm just going to leave it like this because I want you to do the calculations yourself. So let's say this is 175 grams. Just don't forget to convert to kilograms. So that means you're going to go here and you're going to set both of those masses to the same value of 175. Okay, so that's your system balance. Don't forget to enter your units here for mass, for ascending and descending. And the first part of the experiment for trial, there's going to be 4 trials. So for the first part of the experiment, what you're going to do is you're going to add a certain amount of mass to the descending mass. So I'm going to have you read yourselves how much mass you're going to have to enter. That's going to be, and for your experiment, it's going to be defined in step number 2. But I'm going to use a different value. So I'm going to add 10 kilograms or 10 grams to the ascending mass. And so once you have those two masses, you're going to enter them over here. So the ascending mass was 175 grams. Don't forget to convert to kilograms. And the descending mass was 185. And all you have to do is to run the experiment. And you're going to be given a set of data points here. So all you have to do is to copy those data points and then you're going to paste them here. So you have those numbers there. So here then, the next part is you're going to identify the final time and in the final height. So just look here. This is the final. Well, I'll show you a quick way. So if you want to find a final time, you can write it manually, or you can just type equals and then click on the cell for the final time. And do the same thing for the final height. So that's going to be position. And so you have your final height and your final time. And again, don't forget to enter your units for mass and for time and for height. That's going to be the first trial. The second trial, you're going to so the mass difference was 10 grams. So you're going to maintain that same mass difference, but now you're going to increase both of those masses by the same value. So we're going to increase both of those masses by another 10 grams. Actually, just make it 15. So that means if I want to increase both of these, so let's reset. So I want to increase both of these. You're going to keep the same mass difference of 10, but now both of these masses are going to raise by 10. And then you're going to repeat the experiment. So here, this is going to be trial 2. And so in this case here, the ascending mass was 185 grams. Don't forget to convert to kilograms. So let me just clear this off here. And the descending mass was 195. And so same as before, you're going to take these data points, copy them, and then paste them here. And then you're going to repeat what you just did for the last slide. You're going to find last trial. You're going to find the final time and the final height, and you're going to paste them over here. So, and you're going to do this 2 more times. You're going to increase keep the same mass difference, and you're going to increase both of these hangers, the mass of both of these hangers by the same value, while keeping the mass difference the same. And you're going to do this for 2 more trials. So you're going to fill in these trials over here. But I'm just going to work with just these first 2. So you have here, we're looking at 2 trials. So let's see what the next step is. So the next step is that you want to make a graph similar to this one where you're going to show each of the 4 trials. So I'm going to show you how to do this in Excel. So this is a sample, so you can delete that. So here, I'm going to do this a bit technically because normally in Excel, you can just highlight the columns. You can highlight the columns and you can get an automatic graph. But here, what we're going to be graphing is velocity versus time. So you can see these 2 columns are not next to each other. So you're going to have to do a little bit more work in order to do this graph. So I'm going to show you here step by step how I would recommend doing it. So what you're going to do is you're going to go to insert here. And you're going to click on scatter and click on the first one. So that's going to be how to get the graph. Well, let me show you here how you're going to get the numbers. So here you're going to have to do a bit of legwork first though. So what we want to graph to get a straight line is velocity versus time. So we want to graph for both trial 1 and trial 2, we want to graph V versus T. And we want both of these graphs, or both of these lines, to appear on the same chart. So how can we do that? So there's a little bit of legwork we have to do first. So we have to identify the range of both of these trials. So I suggest that you do this on a separate sheet of paper. So first identify, so you can say here for trial 1, what's the x-axis going to be and what's the y-axis going to be. And then for trial 2, what's the x-axis going to be? And what's the y-axis going to be? And you'll have to do this 2 more times for trial 3 and trial 4. I'm just going to do it for the first 2 trials now. So for trial 1, the x-axis, what's the range of those numbers? If you look at it here, the numbers range from this first number here, which is V35, all the way down to the last number here, which is V1001. So you can just write that here. So this is going to range from V35 to 101. And what about the y-axis? So the y-axis is the velocity, and that one is going to range from, if you just click on the first number, it shows you right there, this is the x column. And you can see it over here too, it's highlighted over here, this is the x column. So then for the y-axis, it's going to be x35 to x, or to x10101. Let's do the same thing for trial 2. So for trial 2, the first number is AB35, and then the last number is this one here, which is AB103. So for this one, this is going to go from AB35 to 103. And let's look at the y column. So the y column is this one over here, and this is in the column AD. So then this is going to go from AD 35 to 103. So this is just a rough outline, but let's see how to actually enter this into Excel. So into Excel, you have to take into account that here there are 2 sheets. There's a homework sheet and then there's a lab sheet. So you have to make sure that the graph knows to get the numbers from the sheet that has the data points. So this is going to be the sheet called Lab D. So you have to take that into account as well. So then this is what you're going to enter into Excel. You're going to type, always start with the equal sign, and then the name of the sheet, which is Lab D _ D, and then the range, which is V35 : V101. And same thing for the Y column. So this is going to be actually, you just change that to X. And same thing for these two here. So just change the corresponding values. So this is now column AB. So replace that with AB, AB, and now this goes to 103. And so you can just copy paste that one here. And this is column AD. So this is what you're going to enter into Excel, so that it can graph those 2 numbers, or those 2 graphs, those 2 lines on the same graph. So here's your blank graph. So what you'll do is you're gonna right click and then select data, and this blank area is gonna pop up here. So let's see how you're gonna do this. So create a series, call that series trial 1. So always start with the equal sign, parentheses, trial 1. And here the range for the x-axis was, you can just copy paste, it's this one here. And for the y-axis, it's this one. And let's also create another trial, call that one trial 2. So equal, parentheses, trial 2, and then just copy paste this one here and this one here. So this seems like it's a lot of work, which it is, but there are probably other ways to do it. But mistakes tend to happen. So this one, it's gonna you just do a little bit of preparation, and it'll all come out at the end. So then you click OK. And let's see if we have those sheets or those two graphs. So you can see them right there. Both graphs are shown on the same plot. So you're gonna have to do that for trial 1, 2, 3, and 4. Okay. So other than that, let's see what other components you're gonna have to add. So what you're gonna do is you're gonna click on this one here. You're gonna, I believe you can go to Format, or I think it's Chart Design. Yeah, Format, and you're gonna go to Add Chart Element, and don't forget to include the access titles, and then the chart title, and also let's see here. Also want to include a legend. So include a legend on the side over here. So you can see the legend shows you which one is trial 1, which one is trial 2. And you can make that bigger if you want. So that's how you're going to put both of all of your data points onto the same graph. And the last thing is you'll right click. You're going to add a trend line. And make sure that you select linear and then display equation on chart. And then you can just move it off to the side there and increase the font size to make it bigger. But I'm just going to leave it like that for now. So this is how you're going to create that. So this is the next step. After you get your data points, you're going to create a graph with all of the each trial on one graph so you can compare them. And the slope here, whatever slope you get, here the slope is 0.25. Then you're going to enter that value here. So let's see, I believe the orange one was trial 2. So this is going to be over here, trial 2.25. And let's see how you're going to get the theoretical and experimental acceleration. So to get the theoretical acceleration, you have to go back to the formula sheet. And you're going to use this formula here for the theoretical, using the ascending and the descending masses for trial 1 for the different trials. And then you're going to use this equation here to get the experimental acceleration for trial 1 through 4, using the final height and the final time, which are going to be these two numbers here, the final height and the final time. So these two, you're going to use that to get the experimental acceleration, and then these two you're going to use to get the theoretical acceleration. And then you're going to enter those values here. So whatever. That'll be your theoretical using the difference in masses. And then this is going to be using the final position and the final time. And then you'll get the percent error. And then the last thing is to calculate the error in the acceleration using the last formula. So this one here is going to be using this formula right there. So actually, let's see how to get the error in the mass. So the error in the mass, time, and the height. So recall, so what you have to do here is take all of these to be digital devices. So this is a digital display for the masses. And even these numbers, take these to be digital displays. So the error is going to be find the last, in this case here, there's no fluctuation. So find the last decimal place, or find the last non-fluctuating digit. And the error is going to be one decimal place behind that. And that's going to give you the error in the position, the error in the time, in the position, and the error in the masses. And then so you'll use that to calculate the error of the acceleration. So that was a lot. And let's just also look at trial 2 and see how trial 2 is going to vary from trial 1. So for trial 2, you're going to do the same thing, but there's going to be just a slight modification. Again, you're going to start off with the system in balance. So let's say that the system starts off in balance, with both of them having a mass of 170. So here, then you'll put, well, what was it? They actually start off with the same value. So here they should both be in balance with, yes, 175. So you're going to put over here as well, 175. Don't forget to convert the kilograms. So this is in grams here. And here what you're going to do is trial 1, you're going to increase one of the masses by 10. You're going to decrease the other mass by 10. So you're going to increase this mass by 10, decrease this mass by 10. So it should be 2 times. So, and you're going to run the trial. That's going to be trial 1. And then the second part, you're going to increase this mass by 20, and then decrease this mass by 20. So my numbers are I use different numbers, so they're out of range. So let me just change these starting values then. So let me just make them lower. Let's make it 160. So you're going to repeat what you just did for trial 1, but so we can just concentrate on this part here. What you're going to do in this case for trial 2 is you're going to start off, increase this mass by actually 5, and decrease this mass by 5, run the experiment. And then you're going to increase that same mass by 10, and decrease that mass by 10 and run the experiment. And then increase by 15 and decrease by 15, and so on. And that's what you're going to do for trial 2. But just make sure you read the procedures in detail to get the actual values for the increments for the masses. Other than that, everything repeats. So really the hardest part of this lab is to do the Excel part, to incorporate all 4 of the graphs into one chart. That's going to be the trickiest part.